We won't take much of your time. Thank you so much for jumping on a call with us real quickly. We're actually at the end part of our annual review cycle for the grants, and we had just a couple questions that we wanted to ask you about your project, which is titled Spatial Understanding of Erdheim-Chester Disease, Origin and Lesional Microenvironment for Future Precision Medicine. I'm always like amazed by these long titles. First, I would love if you could just share with us a little bit about what the project is and what the impact will be on the community and research.
So the project is about investigating. So a lot of focus in this particular project is on the neurodegenerative disease. So we will investigate biopsies and postmortem tissue sections from patients, that unfortunately did not make it, but where we have a unique opportunity to have a look, what are the processes actually governing to neurodegeneration. As you may know, in a lot of patients, that's remaining a key clinical problem. We don't know really how to diagnose it early enough, and even if diagnosed, the treatment options are very limited. So the idea there is to understand what is happening at the tissue environment by using, I would say, state-of-art techniques, and that includes, so the first step, what we're going to do is to analyze single cells, so to say, one by one, with so-called single cell techniques. Really trying to depict how the mutated cells in the brain differ from the ones that are non-mutated, because in that case, you would get hints of specificity, what would possibly be possible to target. But then from that step, we would only get, like dissociated cell information. So a lot of super deep knowledge on one single, on each single cell level. So in the next step, we will take that information and try to look spatially in the actual tissue environment. What are the neighbors on those cells? What cues are they sending to each other? And then in the third part, what we do is go in and try to validate those new pathways or signaling cues or markers or checkpoints with the aim to, we don't know what it will reveal, because the first part is very hypothesis-free, so to say, except for the design. And then the second parts are more towards translation, because if you think of it, it would be very hard to use this type of state-of-art technique in the clinic. So for that, we have our third aim, which is to use Maxima. It's like an imaging platform where you can image a lot of antibodies at the same time on the same section. And in that way, you could confirm those key markers, that we came up with in the first two aims. And then that information actually is super easy translatable, because that is the same antibodies that we use in the clinic. It's just that with Maxima technology, we can multiplex up to 400 antibodies. And then the ones that are, mostly predictive, or from the therapeutic point of view, mostly interesting, we could actually use them in the clinic. And the whole background, I did not expand a little bit on that, but like the problem right now is that we actually do have no idea what is happening in the brains of those patients. So if you think of targets, it's of course we have BRAF V600E or inhibitors, but we know that those would not cure the patients by any means, but as soon as you take them off the inhibitor, the disease will come back. So the idea there is to understand the neurodegeneration with the aim to actually be able to target it or somehow use that information in the clinical diagnostics.
That's fascinating. I know that the CNS disease is one of the aspects of some of these histiocytoses that have the most question marks. And so this seems like it would be really, really impactful. So how will the funding help you with this project?
Basically, my research time is funding 50% 50% I do clinical work, and then 50% I have research time. So I will not use any of that for that. And I have a student working with me, but what we will use the 500,000 or kronas, which is roughly $50,000 would be for the combined multi-ohm protocol. So that would be first $200 or $20,000, which would be, and it costs approximately 50 or $5,000 per reaction. And the beauty with that technique is that we combine single nuclear RNA-seq together with ATAC-seq on the single cell level. And this is super expensive, but there's no other way we can differentiate cells, the mutated from non-mutated ones, in the tissue environment. Because like if we want to get, all the RNA data, we also need ATAC. And we think that that would allow us to discriminate between mutated and non-mutated cells. And that's actually a cheaper option, because another option I was having in mind was doing DNA-seq as well on the single cell. And that would be, we could do just like 50 cells or something. But now we'll do huge amounts of cells for these samples that will be selected for the first, like the multi-ohm protocol, which is then RNA-seq and ATAC-seq, single cell ATAC-seq, and then the rest 300,000 would be used. So the first one we will do spatial transcriptomics. As you remember, we talked about how in the first step, we have single cells, but they are dissociated. And then in the second step, we would try to understand how does it look in the tissue environment. And for that, we would do MERFISH. And that would be almost like equally divided between MERFISH and then the third phase where we would use maximum. For that, we will buy just antibodies for that remaining 150 or $15,000. So so it would be ATACs, so multi-ohm, MERFISH, and then the antibodies for the Maxima. And Maxima platform we actually have, so we don't need to pay for that. And MERFISH platform we also have, so we just really need to pay for the reagents of the both. And the same thing with the multi-ohm, because we have all the infrastructure, but what costs is the kits and of course the sequencing cost in the end. Yes. Do you have, does it make sense, or do you want me to explain a little bit more on the?
No, it makes, I mean, as not being a scientist, it makes sense a little bit. I can kind of put it together, but there are lots of things in there that I don't understand as well, but that's okay. That is okay. But the real reason we wanted to invite you on this call was to, yes, hear about your project, which sounds absolutely fascinating, but also to let you know that you have been selected for funding. So we are letting you know that we have selected your project for $50,000. Yeah, we were just so excited to share that news with you and wanted to give you this little extra holiday gift.
Yeah, that's perfect, because it's just right before Christmas. I am very grateful, and we optimized everything and we are just like ready to go. So this would be fantastic news, not only for me, but also for my student. I will text him right away after we are done with this call. Yeah,
Congratulations. It's a really important project and we're thrilled to support it. You're doing amazing work.
Thank you. Yeah, thank you very much. I mean, for us, it means really a lot, because as you know, I'm just in the beginning of my scientific career, and as a PI, and it's like really, really, it feels like it's very encouraging that we are able to do this with the funding from you guys. So yeah, thank you.
And I think that that's going to translate into being very encouraging for the community as well, because like I said, I know this is an area that has a lot of questions and a lot of concerns, because, I mean, everything that happens with disease affects the quality of life, but especially when it has to do with the brain and everything that surrounds that, speech and walking and everything that goes with that. So we're just really excited about this work that you're doing, and just want to say congratulations.
Yeah, thank you. And I agree with you. And the thing is that I mean, just 5-10 years from now, it would have been impossible to get this first-hand, information from the tissue, from the human tissue that we can get today. And of course, that's thanks to our clinical collaborators, Julien Arroche, and people who work with him who were able to collect that type of tissue. But I think back in the days, we would be thinking that, okay, we have to have mouse models or something like that to study it. But now we start to learn that, well, actually those type of fundamental questions about human disease can only be learned from where it actually happens. And then when you have a framework, then you can have different models to answer specific questions that you find there. But it should, we think that it should always start right there at the patient, and then you go to the model or whatever you want to. So I really hope that it would be inspiring and useful for other researchers and community that have also very interesting ideas and super good tools to study mechanistics and things like that. So we will share, as soon as we get something, we will share it right away with everyone.
We also wanted to share that your project was actually ranked first out of all of the projects that were submitted. So in addition to the $50,000 that you'll receive for the grant, you'll also be getting an additional $1,000 to apply towards educational opportunities. For example, the Histiocyte Society meeting or anything like that. So you'll actually be receiving $51,000 from the association because of your incredible work, and congratulations on being ranked #1 out of all your peers.
Thank you very much.
That's an extra little holiday gift for you.
Yes, thank you. Sounds amazing. And thank you guys for calling, because it really it actually is a lot of fun to hear it like that.